I would like to now welcome our next speaker, Philipp Misselwitz. He's professor at the TU Berlin at the Habitat Unit, International Urbanism, and he's an architect, an urbanist who studied in Cambridge and at the AA in London. He has also been teaching in Stuttgart. He's a visiting professor also at the University of Witwatersrand. And apart from teaching, since several years, he's also the head of Bauhaus Earth. And this is also part of the reason why we invited you here tonight. And the Bauhaus Earth is an interdisciplinary think tank, also a maker's lab, one could say. You're trying out lots of things, and you're engaging with the regional and the global network of corporations to think through and experiment with possibilities how to build otherwise and how to think construction in a systemic, ecosystemic way across the disciplines. And I look forward to your talk. Thanks for joining us tonight.
Okay. I made myself very unpopular earlier by wanting to present from my own laptop. Apologies for that. And hopefully I have to be here, okay. So hopefully this will work and not cause any disruption. So before it worked, when we tested it, I guess we need to somehow switch the, oh, perfect. Okay, looks good. Okay, I have to say I'm really touched by these three presentations we already had, and the plate is pretty full. They raised actually many very profound questions and reflexive questions. My contribution hopefully comes as a complement. The material I draw on indeed is related to the work we have done at Bauhaus Earth, where we try to combine climate science and material science, engineering, architecture, crafts, to form a kind of organization that can think around the complexity of the built environment and the building economy system. My language might be occasionally a little bit more crude and banal. I will draw on some numbers and data, but hopefully it will make for a good complement. But I want to start with actually a brush with the sort of modernist legacy. Not sure if historians would actually refer to this as Bauhaus legacy. This is Mies van der Rohe's pavilion in 1929, where we were barely 10 people at Bauhaus Earth. Now we are 60. So 3 years ago, we were asked to join friends and colleagues in Barcelona to design a temporary installation in the environment of one of the most iconic modernist buildings. And this building is, of course, as many of you know, a fake. So the Mies van der Rohe Foundation is very relaxed about interventions by artists and architects and playful kind of conversations with this structure. We started by actually deconstructing the material elements of Mies van der Rohe's reconstructed fake pavilion. And you can see the sort of deconstruction of one of the wall systems in its single elements and then in its primary materials. And you see that it's a perfect example of drawing on very extractive mineral-based materials, as was the language predominantly celebrated and propagated by, let's say, the Bauhaus legacy. Our intervention was something different. You can barely spot it there. It's a sort of, it appears small, but was quite substantive timber structure that peaks over one of the walls here, framing the pool. And working with the language and admiring also the language of Mies, we tried to sort of propose an engineered timber structure that was based on locally sourced materials and various bio-based kind of additives to form a sort of viewing platform, conversation space in dialogue with Mies, which was accompanied by our science team that was doing life cycle assessments and ecological footprint measuring of each of these materials. And maybe it sounds a little bit dumb, but of course we came to the conclusion that whereas the Barcelona pavilion had a rather high kilogram CO2 equivalent of more than 1,200 kilograms, the timber pavilion was actually carbon negative. It actually stored more carbon than it emitted in its production, considering the entire kind of value chain from sourcing to producing to application. We also looked at the kilometers that materials travel to feed into the reconstructed Barcelona pavilion and ours, and came to a similar contrast. These are the two figures there. But in the end, our provocation in this kind of space was supposed to create a kind of a conversation and dialogue about material languages, about the systemic footprints that materials leave in the ecosystem. And it was a rather polite dialogue, which also replaced this famous wall with some experimentation of a kind of laser-cut mass timber plane. But also it was each material kind of intervention existing and also new was accompanied by this sort of nutrition chart, hoping that visitors of this installation would somehow understand the ingredients and also the complication of the abstract sort of category of carbon inherited in this material process. We worked with also designers and communication artists to translate these kind of carbon footprint also in analogous kind of muscle training and kind of running videos. This seems a rather, maybe provocation in a very specific environment of an iconic architecture that speaks maybe to an architecture or kind of cultural community. This is not really what we do. Our work is actually more geared towards what one might call a kind of mainstream architectural challenge. And I want to call up some numbers again, which many of you probably know, but I think they deserve mentioning again. What is at stake? What is at stake in terms of material consumption in the world? And call again into this room the kind of urgency of actually acting. We know that we will have something between 2 and 3 billion new dwellers in cities, mostly in the global south. We know that we are likely to double the buildings that are out there in the next 20 years. We know that if material practices that are established today continue, we are likely to have 3 times as much land consumed by structures, infrastructures, roads, buildings than now. And this leaves not only vast, dense kind of built-up areas, but also footprints that extend deep into landscapes and leave sort of extractive landscapes, operational landscapes, serving this huge kind of material orgy. Scientists already know that we have on Earth, for the first time since 2021, more anthropogenic mass than biomass. So our planet turns into a body full of artificial limbs. And this is a kind of lose-lose situation where we already have a building sector contributing more than 40% to global greenhouse gas emissions. We know that currently operational carbon may be the key emitter, but we know that in a few decades, embodied carbon related to the extraction and assembly production of materials and its wasteful afterlives will be more than half of that. And at the same time, we have a really weakened ecosystem that actually is turning from a carbon sink and a safe haven for biodiversity into an carbon-emitting kind of a system where biodiversity and ecosystems have been degraded and are under serious pressure. We were set up by John Schellnhuber, the climate scientist who had the founding idea of Bauhaus Earth in 2019 when the centenary of the Weimar Bauhaus was celebrated. So one of his projections already in terms of global warming takes us this year way beyond 1.5 degrees agreed in Paris. It will take us definitely above 2 degrees, and the question is, do we continue our material practices, business as usual, taking us into fantastic kind of warming ranges that might make our civilizations as we know them now rather unthinkable, or are we trying to kind of manage this so-called overshoot, and I'm borrowing here kind of climate science vocabulary, to keep as close as we can beyond 2 degrees to establish a sort of climate neutrality, but climate scientists would say this is not enough. We need to actually also engage in overshoot management. We need to extract again CO2 from the atmosphere, create negative emissions to work our way backwards into cooling back to the safe operating space between 1.5 and 2 degrees. Considering the amount that the built environment construction is invested in the upshoot of atmospheric carbon and global warming, our question is, can also the built environment and construction economy be part of negative emissions, be part of a planetary regeneration and cooling? And this, and I'm building on the foundational experimentation and research that my colleagues have presented, and I share the kind of curiosity and interest in actually radically rethinking the material palettes that we built with. This drawing shows the sort of the ancient carbon pool that was created over millions of years of terrestrially bound carbon, which has easily during industrialization and with our material practices in construction been blown up and shot in the atmosphere. So how do we actually, with what sort of material practices, with what approaches do we reverse that, and what is the material palette that we then need to build with? We consider the material palette as an open, plural, and diverse table where solutions need to be found often very locally. Often this is referred in the discourse as a mixture between sufficiency, avoiding, also improving existing, decarbonizing existing approaches, such as concrete and steel through different aggregates, or decarbonization of the energy needed to produce concrete. But we are mostly interested in shifting the material palette, discovering material practices that are currently not applied, and promoting its circular application. And again, a complicated drawing, I apologize, but a scenario of how this material palette might need to shift between the material intake today and something like 2060. So you can easily read this graph, hopefully, with the large portion of cement represented as gray that makes up the majority of the material palette today, together with steel, aluminum, and other mineral materials with only a tiny amount of actually bio-based materials. So that needs to change. But at the same time, the circularity component, the degree of secondary wood, of wood with many lives, of concrete with many lives, steel with many lives, needs to be built into that transition project. These are the hatched surfaces, so the notion of avoid, shift, and improve is somehow integral. And although we do not really believe in a construction world without new concrete, concrete alone will be needed to repair the existing mass and give new leases of life and durability to what's already been built. But there is somewhat of a reversal of material streams. This is what material flow analysts know until 1945, roughly, the time of the sort of breakthrough of modernist thinking. The majority of material intake into material practices in cities was in fact bio-based and also geo-based, so that's the green component. This has radically changed, and we need to work our way somehow back towards a different flow mix. And we need to think these kind of materials not just as materials in there with imminent properties and logics and carbon sequestration or storage potentials, but we need to think materials as they flow, materials in systems, from where we might harvest them towards how we enter them in building cycles and keep them as long as possible across many, many different lives. It's called cascading optimization in technical terms, and to avoid what we do now, that bio-based materials is very, very quickly thrown out of the building cycle, wasted, or worse, actually used for energy production. And this also requires us to sort of think about landscapes and cities in a new sort of entangled ways, or we call it the entanglement of technosphere and biosphere, because we need to know, and this is not usually the remit or the horizon of thinking for architects, not to pick materials from catalogs, but to actually think where materials come from, how they're harvested, if they're sustainably harvested, how can they maybe contribute, also create, like the bark beetle, maybe incentives for forest restoration, for transitions from plantation forests to mixed forests, and bring value to rural communities to actually steward and care for ecosystems, and then be inserted and kept in a kind of circular way in urban systems. And this idea of architects and planners becoming more like scouts, material scouts, sort of spotting local, regional opportunities of working with hybrid solutions, with found materials, with existing bio or geo-based materials, is represented here by a graphic actually prepared by colleagues and former fellows of ours for the northern English region of Yorkshire, where material mapping is the beginning of a kind of design process and an understanding how different materials might have different properties, fulfilling different functions, but also leave very different imprints. And it's this thinking that requires us to think beyond and crucially of different scales, whereas architects are usually working in situated contexts. It is necessary to think around regional, bioregional, kind of global entanglements, as well as the material scale. And I want to use the remaining time to give some sort of very specific examples about how we work systemically in different regions around the world, which have very specific conditions, very specific pressures on ecosystems and also urban systems, and how through a way, an approach of systemic re-entanglement, we can reconfigure material flows and value chains to benefit both nature and people. Bhutan is in the Himalayas, a tiny country, has a very lively kind of indigenous tradition of building actually 100% with locally resourced materials such as timber, bamboo, hemp, clay, earth. And it is beautiful to see how villages access forests, and it's almost like a ritual of hunting and dissecting, taking what is needed, carrying it out of the forest into local craftsmen, and then producing building elements of mostly clay-based, earth-based, rammed earth-based structures. But these traditions, these material practices in rural Bhutan and across actually the Himalayas have not made it into the valleys, which have been urbanizing fast and based on material practices that are based on concrete and steel, whereby base components is simply reduced to scaffolding or temporary interventions of furniture. So an entire kind of competence, there was a missed opportunity to actually draw on the very rich indigenous tradition and translate this into, to feed into urban typologies for denser, higher buildings and also lifestyles. So this is exactly our starting point. We were invited to work with the local government, with also local NGOs, to actually rethink this and try to understand a more productive coupling of building systems and natural systems across a range of different materials, such as wood, bamboo, hemp, or earth. And I'll just give you small examples of how the kind of experimentation that was always drawing on indigenous, kind of sometimes ancient precedents, led to a series of rigorous experimentation and cooperation also with construction companies in order to produce building elements that could feed into the building economy easily. This is an experimentation with hemp as a aggregate for earth blocks. This is an experimentation of engineering bamboo, which is an amazing material, storing 3 or 4 times as much carbon as timber. These are pilots that we then implemented that test these light engineered solutions, always in combination with recycling and other kind of material intakes. And just an example of the most maybe promising value chain, which is of course timber, spotting the sort of processes that timber flows through and trying to identify how maybe a lack of rigor in the management of this material, as you can see here, leads to a lot of wastage. What can be byproducts of cut-off parts of timber? What can be made of sawdust? Trying to kind of optimize, create kind of waste-free, probably impossible, but radically waste-reduced kind of value chains. And I'm racing through some of the current experiments and some of the future attempts to bring this actually into building structure in Bhutan we are currently working on. And I want to give another example which is bringing us back to Germany, particularly Brandenburg, where we can also, where I want to illustrate how we can also discover and scale opportunities between landscape restoration and urban transformation here. I want to talk briefly about peatlands, and maybe some of you know that dried up peatlands have become one of the key emitters in landscapes, making up 8% of the German carbon emission overall. It's a huge figure, and in many regions in the north of Germany and also in the south, this is the key emitter more than industry or transport. These are the regions where peatland has been dried up, and European policy and also German policy has become aware of the disastrous impact of a previously carbon and methane storing landscape, highly biodiversity rich, and the kind of pressures that it has received over cycles of overproduction and intensive farming. So a lot of money is being mobilized to try to persuade farmers to actually re-wet this land and adjust their kind of agricultural practices. But these approaches are often equated with dictates from top to down, bureaucrats in Berlin or Brussels dictating change of lifestyle. It's often a fuel for populist mobilization in the countryside, because it is suggesting that current livelihoods of dairy production or farming are no longer needed, and farmers have existential fears for their livelihoods. So what we have tried is to partner with a re-wetting project in the north of Angermünde, which had its prescribed pathway to become a nature protection area, maybe with 1 or 2 water buffaloes and an observation platform for tourists, highly contested locally. And we were experimenting with what can be drawn from the biomass growing on this re-wetted land. Re-wetting is actually a very simple process. You just need to fill up drainage channels and keep water that is in the ground in the landscape rather than drain it away. So we were experimenting together with our fellows, material cultures from the UK, into the vast range of potential building products that can grow on this re-wetted land. I won't go into detail, but we built and exhibited prototypes and fabrics, and discovered that actually on this 60 hectares of re-wetted land, materials, 40 to 60% of material demand for 60 houses can actually be harvested and produce potentially an economic pathway that might be more attractive than highly subsidized and agriculture. We've started to use these locally sourced experiments that are currently still in a kind of niche production stage in Germany. There are plenty of actors that experiment around these things, but like a chicken and egg dilemma, they never reach progressive construction companies or clients or architects who actually want to apply these materials. So what is needed is a lot of confidence building around these value chains and connecting dots, bringing investment for these products to be scaled. Our kind of exhibits, one-to-one exhibits here in Potsdam or in Berlin is one way to do that, but of course it requires also the competence of economists. It requires investment companies, finance companies, banks to be mobilized, and trust needs to be built around those kind of material flows. And I want to end up with another experiment where we also work with a real-life client. In this case, it's in the north of Berlin, in Weißensee, a construction company transforming its own construction yard as its new headquarters, where we try to connect 4 or 5 different material innovations to radically reduce the carbon footprint of this transformation. This is, for instance, cutting apart an existing concrete slab in the yard of this Gewerbehof, and rather than grinding it down and then using it as landfill on Brandenburg landfill sites, it is actually turned into slabs and then stacked up and used as a foundation for a construction of a building nearby. This is what is happening. This was happening in the autumn, so now the entire foundation layer is used, reducing the intake of cement to a minimum and saving up to 60% of carbon of the overall construction. Then we also experimented with actually using construction earth from construction pits and investigating its properties and discovering that they can easily be pressed to form air-dry earth cement bricks, where they're not carbon storing, but the processing is so light that energy is required for pressing but not for drying. So it's a very attractive alternative for a lot of brick kilns that have gone out of business because energy costs have spiked since the Ukraine war. So it's very easily actually to scale, to feed into an economy that in Germany is a lot about masonry. 40% of construction material in Germany is masonry. And we have not only produced and started to apply bricks of various sizes. This is an experiment with Sauber-Hutton architects of creating different kind of surfaces and shapes, but also using these kind of prefabricated earth blocks in ceiling structures in between wooden joists, where often steel and concrete is being brought in because of its mass to deal with sound insulation requirements. And this is simply showing how easy it is to produce these kind of bricks with existing infrastructure that is lying idle in many former kilns in Germany. And here, how easy it is to insert an earth grey brick into ceiling structures. It's a perfectly circular material. And I end up with another provocation, which was a personal reward for campaigning to keep some of the East German legacy in the center of Berlin. About 25 years ago, the Palast der Republik, we were able to install some of our kind of regional material products actually vis-a-vis the newly built up castle you can see there in the distance, and show right next and on the site of the former Schinkel Bauakademie, next to the existing kind of fake corner there, what regenerative architecture might look like in the future in Brandenburg. Thank you very much.